Good day, I am of Junior S. Dalanon, and today I will be presenting my schematic diagram of a common emitter amplifier circuit and how to simulate it. The circuit I made is what we call the common emitter amplifier circuit. It is a circuit that has a resistor in its collector circuit. In this circuit, the current that flows through this resistor produces the voltage output of the amplifier. This circuit also uses what is more commonly called voltage divider biasing. This type of biasing arrangement uses two resistors as a potential divider network across the supply with their center point supplying the required base bias voltage to the transistor. Voltage divider biasing is commonly used in the design of bipolar transistor amplifier circuits. And now this is the circuit that I made, and as you can see, it is uh, an example of a simple common emitter amplifier circuit. And now we'll go to simulating it. First, we should do a transient simulation, and I'll just put here 5 ms and try to run it. Now you'll see for us to see, we'll have to add some traces if we want to see like the V in, V out, IB, IC, IE. And let's just add some planes so that we can arrange them. Now this is like the normal simulation of the common emitter circuit, amplifier circuit that I made. But for us to compute the things like output power, gain, and bandwidth, we'll have to do an AC analysis. And to run this AC analysis, we'll have to again edit the simulation command. Click here the tab of AC analysis, and type of sweep is decade, and I'll be putting here 10 for the number of points per decade. Start frequency 10, and stop frequency will be 100 mega. 100 mega. And now okay. Now if I try to run it again, wait, I'll just close this one. Try to run it again. Since I've run this previously, here is the results. Now for you to get the gain, the formula of gain is V in over V out. The V in here is 20 millivolts, but for us to get the V out is you'll have to find the maximum gain of the V out here. So to do so, like what I did here, is you'll have to first left click this one and put it in linear. Now you're in linear, you'll just have to right click this label, and you'll be getting this window, and here you can drag here. Now for you to get the maximum, like the peak one, you'll just have to look at here the magnitude, which is also the voltage. And as I resulted here, I got this 3.2708756 volts as my magnitude. Then my V in was 20 volts, so This magnitude over 20 millivolts resulted to a gain of 163.54378. But what if you are to find the gain in decibels? You just have to again left click this one and just put it here, decibels, and now you'll find it here. The same thing I did is like I just click right click here and then I drag here to find the max decibel. But the formula for decibel will be the gain in decibel will be slightly different since you'll have to use the formula 20 log times V in over V out, and it resulted to a V out of 10.29328 over 20 millivolts. Then I multiplied it to 20 log, which resulted to a gain in dB of 96. But now, the last part here is how to get the bandwidth. The bandwidth here is, since you have this one in decibel 10, you'll just have to subtract 3 decibels, approximately 3 decibels, and add another 3 decibels to find the what we call upper cutoff frequency and the lower cutoff frequency, because the formula for the bandwidth is upper frequency minus the lower frequency. And here I resulted to 273.05457 hertz as my lower frequency, and for my higher frequency I resulted to 46.96286 megahertz. Now if I were to use the formula, which is higher frequency minus lower frequency, I resulted to a bandwidth of 4.9625869453. It is not that much since the lower frequency is only in hertz, and when you convert it into megahertz, it's not much to subtract into the higher frequency. So that is all for this simulation, and I hope that I'm clear about how to solve and how to simulate this common emitter amplifier that I made. Thank you.